Distance, rate, and time. Okay, fasten your seatbelts because this is one of the most difficult things in algebra to do. But one of the reasons it's the most difficult thing in algebra to do is because they use strange methodologies and they really don't do it right. And when I say they, I'm not wild about the way Mr. Wallace does it, but that's okay. I have never read an algebra book that in my mind does this correctly. I've gone on YouTube. Nobody on YouTube does it correctly. Nobody on the internet does it correctly. So the method I'm going to be teaching you, nobody uses except me and the students that I've taught. But distance, rate, and time is distance equals rate times time. It's also called bodies in motion. Distance equals rate times time, or abbreviated, D equals RT. That is, D equals R times T. D stands for distance, R stands for rate, T stands for time. Now, distance I think we understand, time we understand, rate is velocity or speed. And we talked about that in one of the early lessons. I'm not sure why they call it rate, but that's okay. When it comes to math and we're talking about speed, we use R, and that stands for rate. Now, bodies in motion assumes two bodies in motion. That is, it could be a person, it could be a train, it could be a plane, it could be a bullet, it could be just about anything. But there will be two bodies in motion. And so we use D1 equals R1 times T1. That is, D equals RT for the first body in motion, and D2 equals R2 times T2, which is just the same thing. D equals RT, but for the second body in motion. We got to keep track of them separately. And just so you understand this, distance equals rate times time. What if I told you that the time was 4 hours? So the distance would equal R4. That would be R times 4. Now, what if I told you that the rate, or the speed, was 30 miles per hour? So now we have 30 times 4, so we know our distance is 120. Now, if it's 30 miles per hour and it's 4 hours, we know that the distance is going to be 120 miles. But it could be kilometers and it could be a lot of different things, and we're not going to get into that right now. I just want to show you how DRT works. Now, you'll hear me say DRT, and that's just short for D equals R times T. Now, I told you that these problems were very complicated. Well, they're complicated because there's 6 variables when you're talking about bodies in motion. That is, two bodies in motion. You have D, you have R, you have T, and you have it for two bodies. So that's 6. And then in some of these problems, we have 8 variables. That's why we don't want to use a lot of different methodologies to solve this. You're going to see when we break this down, it's going to be a lot simpler to solve. And then, of course, whether we have 8 variables or we have 2 variables, what are we trying to do? We're always trying to get it down to one variable. So keep that in mind as we look at the first problem. 2 joggers start from the opposite ends of an 8-mile course running toward each other. One jogger is running at a rate of 4 miles per hour, and the other is running at a rate of 6 miles per hour. After how long will the joggers meet? Okay, this is a system that we are going to be using, and this is a system that we use for every problem that we are going to solve with DRT. Now, if you go through any math book in the world, they will give you different systems to use depending on what you're looking for. Me, I don't care what you're looking for. This is a system that you will always be using. So you're not going to have to memorize a bunch of systems, or you memorize a bunch of systems and then try to think which is the right one for this problem. You're not going to have that worry. So D1, R1, T1 is the first body in motion. And on the side I wrote J1, which is the first jogger. And the second body in motion is D2R2T2, and that is the second jogger, so I wrote J2 on the side. Now if you're working with a problem that seems a little confusing, it's always good to draw a little bit of a map. And what I have here is I have a distance of 8 miles. I have one jogger starting here, the other jogger starting here, and they're moving toward each other to the center. Now, what is the distance for the first jogger? We don't know. What's the distance for the second jogger? We don't know. What do we know? Now, if you're given a DRT problem and you don't know what the distance is, this is a good question to ask yourself. Is the distance you are given the total distance? Do we have two objects moving toward each other? Well, in this one we do. They're starting at 8 miles apart and they're moving toward each other. So the answer to the first one is yes. Do we have two objects moving away from each other? And so that's the same kind of a problem, except that they're starting in the middle and they're going to end up on the outskirts. That is, they'll end up 8 miles apart. Now that's not what's going on here, but you're going to see that in a lot of problems coming up. Do we have one object making one trip at different speeds? And let me give you an example where that would be the case. Somebody's running to the store, and after a while they get tired, so they walk the rest of the way to the store. Well, to the store sounds like one trip, but it's really two. The first portion of the trip is where he's running, and the second portion of the trip is where he's walking. And so we'll divide the problem up that way. And we have a problem like that coming up, so you'll see what I'm talking about when we get to that. But right now, what do we do when we have the total distance? Like we discussed. Jogger number 1, we don't know how far he's jogged. We know it's less than 8 miles. And jogger 2, we don't know how far he's jogged, and we know it's less than 8 miles. The only thing we know is that together they have jogged 8 miles. That is, the total distance is 8 miles. So what do we do with that? Is the distance you are given the total distance? Well, we decided that it was, and it is. And so what is the total distance? Instead of D1 or D2, it's D total. That is that D sub T. So we don't know what D1 and D2 are, but we do know what the total is. Anyways, so that we can properly use this, we are going to subtract D1 from both sides. Now you could subtract D2 from both sides. It doesn't matter. It really doesn't. But just to make life easy on ourselves, we're going to subtract D1 from both sides, bring it down, and now we see that D2 equals D total minus D1. And that's what I just showed you. D2 equals D total minus D1. And what is D total? It's 8. The distance that both of them travel is 8. And so for D2, we're going to put 8 minus D1. So right here, let me put D1. And right here, let me put 8 minus D1. Now, do you see what I'm doing? I've eliminated a variable. I've got D1 and D2 listed as D1. Now, D1 is D1, but D2 is the relationship to D1. Okay, so I'm not going to put 8 minus D1 for D2 and 8 minus D2 for D1. It doesn't matter which way you do it, but you can't do it for both. Both of them need to be D1 or both of them need to be D2. Now, if you go back to the problem, you'll see that the first jogger was jogging at 4 miles per hour and the second jogger was jogging at 6 miles per hour. So let's list those. R1 is going to be 4. And R2 is going to be 6. And for time, they did not give us a time for jogger 1 or jogger 2. As a matter of fact, that's the question. After how long will the joggers meet? This is a good question to ask when you hit a stumbling block like that. They didn't give me the distance. They didn't give me the rate. They didn't give me the time. Ask this question. Does T1 equal T2? Does D1 equal D2? Does rate 1 equal rate 2? In this case, T1 does equal T2. In other words, they start at the same time and they finish at the same time. So we're going to put down T1 for both of those. You could put down T2 for both of those. It doesn't matter. They're the same. But the point is we're trying to reduce it down to one variable. And if you look at our list now, we started with 7 variables and we've got it down to 2 variables. There's only 2 variables listed here, D1 and T1. And once we have all 6 of these slots filled in, we can start building 2 formulas. The first formula will be D1 equals R1 times T1. And I think it's pretty simple to see that if D equals R times T, then D1, looking at jogger 1 now, D1 equals 4 times T1. Let's write that on the board. Just like that, and so we have a formula for jogger number 1. Now let's put together a formula for jogger number 2. Well, D2 equals 8 minus D1. So that's going to be, as we do our D equals RT, 8 minus D1 equals 6 times T1. Do you see that? Look at that for a while before we put it up on the board. D2 equals 8 minus D1. But that D is going to equal R times T. That is, D2 is going to equal R2 times T2, which is going to be 6 times T1. So let's write that on the board. There we go. And this D1, we don't know what it equals. This T1, we don't know what it equals. That T1, we don't know what it equals. But look, we do have one variable that's alone. D1 is alone here. Now I know we could get this D1 alone if we got the 8 over here, but we're not going to do that. You could, but we're going to take this D1. We know what it equals. It equals 4T1. So why don't we insert that right here, okay? This is D1, and this is D1. D1 equals 4T1. So why can't we just substitute that in there? Well, you know that we can. We've done that before. So let's do that right now. Well, there you go. And remember, there's a minus sign. Don't lose that minus sign. And, oh my goodness, look what we got. We got one variable. We have gone from 7 variables down to 1 variable. And you know what that means. When we have 1 variable, we can solve for it. That's right, we're going to get all the variables on one side and all the units on the other. And since all the units are already over here, we're going to get this unit over here, negative 4T1, positive 4T1. That's going to zero out here. So let's bring everything down. Bring the 8 down, the T1's zero out here. And 6T1 plus 4T1 is 10T1. Divide both sides by 10 and that will isolate our T1. And T1 equals 8/10, right? Oops, you already know that's not correct. We got to reduce that. And T1 equals 4/5. 4/5 what? Of an hour. And that was the question. How long will it take them to meet? Well, it'll take jogger 1 4/5 of an hour to meet, and since they are both operating on the same time, T1 equals T2, it's going to take the other guy 4/5 of an hour to meet. So that's the answer to the question, 4/5 of an hour. Now let's go back into the grid and fill in the rest of the numbers. And that's a real good way to check your work. Okay, T1 was 4/5. T2 was 4/5. And so D2 equals R times T, R2 times T2. So that would be 6 times 4/5. Do you see that? Take the time, look at that. It's 6 times 4/5, which is 24/5. And for distance 1, we have 4 times T1. T1 was 4/5, so 4 times 4/5 is going to be 16/5. And so 16/5 and 24/5 is 40/5, or 8 miles. And that was correct. The total distance was 8 miles. Now, they didn't ask us how far the first jogger jogged, and they didn't ask us how far the second jogger jogged. But I like to fill in all these slots because at this point, the work is really easy, and it's a real great way to check your work. And if all of this doesn't pencil out, start all over again. I want you to take this problem and do it all over again. I want you to do it on your own. And I really don't want you moving on to the next problem until you've got a handle on this one. I've walked you through the whole thing. I just want you to repeat what I've done. And you're going to see I believe we're doing 5 problems in this lesson. And by the time we got done with the 5th one, you're going to have a pretty good handle on what we're doing. But I want you doing this work on your own, not just watching me.